Hi, everybody. Thanks for sticking around today for the graveyard shift, but sometimes they say they save the best to last, so let's hope we don't mess that up for you. Has anyone, who's from Berlin, by the way, here? Okay, great. I'll come and speak to you after because I'm looking for the best part in Berlin tonight because this is only my second time in Berlin. Who here has heard of JetStack? Anybody? Oh, a couple. Oh, good. Who's heard of Cert Manager? Great. Who's heard of Venafi? Nobody. Who's heard of SPIFFE?
I thought you were going to say who has heard of CyberArk.
Who's heard of CyberArk? Okay, so my name's Matt Barker. I was the co-founder of JetStack, and we are best known for being the creative cert manager, which is I guess the de facto way of doing certificate management lifecycle in Kubernetes, downloaded 18 billion times a year, believe it or not. And we started 9 years ago as a Kubernetes consultancy. In the process of creating a consultancy, we spotted gaps, we created Cert Manager. We were then acquired by Venafi, which is what they call a machine identity management company. We were then acquired by a private equity company called Thoma Bravo, and then on Monday, we were acquired by CyberArk. So if anyone wants to know about integration and various acquisitions, I can give you as much information as you possibly want to know. But today we're going to talk to you about SPIFFE, which I am genuinely excited about. And so we'll talk to you a bit about what it is and how it helps you solve something called Secret Zero. And we've also got my fabulous assistant, Mattias.
Hey, nice to meet you all, yeah. Have been working for Matt for the last 6 years, joined JetStack as one of the early employees, and now working with Matt on everything SPIFFE related, and also really excited to talk to you about this today.
Yeah, thanks, Mattias. So yeah, we've done introductions. So what are workload identities, problem solve, SPIFFE, Spire, and then some questions. So there's a lot of things going on right now if you're a DevOps engineer or even running a CISO, a CTO, even just a CEO. Obviously, I don't think anyone here needs to know that cloud is growing, but it continues to accelerate. I saw 5-6 years ago, I saw these adverts saying that friends don't let friends build data centers, but data centers seem to continue to hold on for dear life. And I cannot talk to you about a company that I work with or an enterprise, especially a Venafi customer, that doesn't have a large data center estate. So that remains in place. Clearly, whether we like it or not, multi-cloud becomes the norm. I don't know whether people actually have some grand strategic plan around the multi-cloud strategy they're going to have, but obviously we're all running in multi-clouds now. Kubernetes is clearly the operating system of the cloud. I think we can all agree that's the case. And then because we're designing architecture that lends itself to microservices, then workloads, whether that's a container or a bash script or anything, a piece of code, explodes. And as that happens, it becomes very difficult to manage this sort of explosion of workloads because complexity goes up in these multi-cloud environments across data center. Very hard to do operational efficiency with that. And obviously the risk increases. Venafi became very successful off the back of risk increasing the risk of outage. So an outage basically by a certificate not expiring, so they manage that process to make sure that doesn't happen. And I think there's a quote here from the CISO of JP Chase, which I think actually, I was quite surprised he admitted this, but it kind of illustrates the point very well. He's saying that his platform engineers are more important to the security of their cloud-native environments and to Kubernetes than the security teams, because the security teams just don't get it. And I'm sure many of you will remember when there was almost a barrier between ops people and developers, and obviously we broke that down with DevOps, but we're in a similar world right now where I feel like platform engineers are going out and building this amazing cloud-native infrastructure, but the InfoSec team have traditional tools. They don't have the knowledge, perhaps, as much as we'd like them to, and it kind of creates this barrier, and that was alluded to by the CISO of JP Chase. So we have this problem. And we feel like some of these problems can be solved with workload identity and with SPIFFE. So what is a workload identity? Well, we're all pretty familiar with human identities. Well, at least I hope we are. And we split it up into two parts. So we have internal human identities, which could be permanent employees, contractors, gig workers, and then external, which would be customers, partners, vendors, consultants. Hopefully there's not much confusion or disagreement with that. On the other side, we have machine identities. And so I mentioned before that Venafi is a machine identity management company. So we think about machine identities in two parts. So we have workloads, which, like I said, could be a container, a process, application, or service. And then you've got physical devices as well. So is that a server, a virtual machine, a laptop, an IoT device, a mobile device? And this is the way that we think about it and break it down. Anything to add, Mattias?
Nope, perfectly explained.
Okay. So if you think about the scale we have here of human identities on one side and machine or workload identities on the other side, I think hopefully a lot of you will agree that we've kind of got human identity fixed. I mean, I wouldn't say it's perfect, but we have PAM solutions, we have IAM solutions, we have Okta, we have et cetera, et cetera, et cetera. And we've Active Directory, we have this huge sort of massive trillion or however billions of dollars of industry around managing and protecting human identities. It's very well understood, they're very visible, there's fewer to manage, they're manual, and hopefully they're longer lived. Whereas on this other side over here, for your average InfoSec person, they understand how to manage human identities because they have the tools for it. What do they do with all of these workloads and machines? They're often very short-lived. We know that Google's moving to 90 days cert renewal, for example. They're often automated. There's a lot of analysis that says that machines outnumber humans right now by 10 to 1. We think it's 40 to 1. It's likely going to increase to 100 to 1 pretty soon because microservices are just exploding. And they're less visible and less well understood. Anything?
Yeah, and like with functions, for example, like a service as a function can live like for 2 seconds. But it still requires an identity to be able to do things. So like that's why it's like really short-lived as well.
And the impact of a breach here is just as important as the impact of a breach here. And we're kind of breaking down the perimeter right now. So in the past, we used to think about our infrastructure as a perimeter. Now all of our workloads are everywhere, running in any environment. So we have to think about zero trust. I mean, I know that a lot of people talked about zero trust today, but we think identity can help with that. But who cares? Well, this guy, without getting too philosophical about it, this is Aristotle, who said that an entity without an identity can't exist because it would be nothing. And so why then, in our organizations, are we running all of these things that don't have identities? How does that affect your ability to get visibility of your workloads? How do you manage it? How do you protect it? And then with AI coming in and workloads becoming more autonomous, how do you protect yourself potentially against it? And so that's what we're thinking about today. So when we think about applying an identity to a machine, there are a lot of different ways of thinking about identity. So there isn't just one. There's, in some cases, dozens. And they're all over the place. And yet we capture our human identities relatively well, but we don't particularly capture our machine and workload identities in the same way. And I think about like playing Pokemon and needing to capture all these identities. And so just very simply, what Venafi does is it gives you this control plane to get visibility of all these identities and then manage the life cycle, apply policy, apply control, apply governance to them. So that's what Venafi does. Today, what we really care about, and this is where I think the real innovation comes in the space, is around this particular identity type, which is SPIFFE. And I know only 3 or 4 of you, I think, had heard of SPIFFE before. I think you're going to get to know a lot more about SPIFFE over the next few years. Why? Because of this guy. Does anyone know who that is? That's the founder of Kubernetes, so that's Joe Bader. So him and a couple of other guys, Craig and Brendan, founded Kubernetes in June 2014, so 10-year anniversary this year. And when he launched Kubernetes, he referred to it as GIFI, which means Google Infrastructure for Everybody Else. And then he was thinking, well, in the future, when Kubernetes becomes the operating system of the cloud, maybe there's going to be a time when workloads explode and they're going to be running everywhere. And Kubernetes can run in any location, in any environment. So therefore, I should probably think about creating a way of protecting those workloads. And so we should probably apply an identity to it. So when he launched GIFI, he also launched something called SPIFFE, so Secure Production Identity Framework for Everyone Else. And this also took the patterns that he'd learned about and implemented at Google and applied it to identity. So SPIFFE is created by the same person that created Kubernetes. And I mean, I only learned that recently, but that blew my mind because this guy has got some serious vision. And so that's what it stands for. Secure Production Identity Framework for Everyone. And that is an example of a SPIFFE ID. Mattias, do you want to just explain the ID?
Yeah, this is how you identify your workloads in a unique way. In this case, it, for example, can identify a web server of the front-end service that runs in Data Center 1. Later on in the talk, we're going to talk a bit more about in depth about like SPIFFE identities and how we can verify them.
And it's becoming important for a number of different reasons, but one of them is the cloud vendors are now adopting it as a standard. So Google announced a workload identity product last summer. We're working right now with Amazon and Azure, who are both working on workload identity products. But on top of that, SPIFFE was donated to the CNCF, it's graduated. We know it's being adopted by the industry. It's also a fundamental part of Istio. So if you use Istio, then it's backed by SPIFFE. Obviously, we know about SolarWinds and failure to protect identity leading to supply chain attacks. But there's also a zero trust mandate and regulation pushing people to think about zero trust and this perimeter breaking down. So how do you think about that? And one of the best ways of thinking about zero trust is by using identity. And we have some pretty big challenges to solve right now. The first thing is that every single one of these environments or every single different type of workload right now has a different type of identity. So you end up with these different identity silos in all these different clouds. You also have different identity types between on-premise machines and cloud workloads. So you have to think about your identity on-premise in a different way to your cloud environments. You have secret store, so people just spin up a vault more often than not, secret store, stick their identities in it or CA or whatever it is, and you end up with this sprawl and complexity and leakage. And every time you create a new secret store, you have to have a master password, but where do you store the master password? You then have to put it into another secret store. So you end up with this, what we call a secret zero risk. And it's almost like an infinite regress, which is actually what the turtles represent, because it's turtles all the way down. And if you create another turtle, you create more risk for yourself. So this is a real issue right now, and we have a lot of customers talking to us about how they solve this problem. So if you just stop and imagine a world where every single entity in your estate is given a unique and consistent identity, what can you do with that? And that's really where we're asking you to go with SPIFFE, because once you've done that, you get the option to do some pretty powerful things. At that point, you get a consistent identity for any cloud workload in any environment. It's not just Kubernetes and platform people that get to benefit from this now. You also get your infosec and security team being able to apply a SPIFFE identity to their physical machines in on-premise environments. You get rid of secret zero because you don't need it because you're using identity to do it. And there is a point in time in the future where you might not even need to use Vault at all, or a secret store, not just Vault, any secret store. And I know that's quite a big concept to think about, but it's true. And we've actually seen this in reality with customers. So this is the quote from Joe. And at this point, I'm going to hand over to Mattias to talk to you exactly how SPIFFE actually works.
Thanks, Matt. So we're also first going to start a bit with the workload identity pyramid. And like with every pyramid, we require a strong base, and that's where we provide the identity. The second part of the pyramid is the authentication part. With SPIFFE, we're going to get that through our CAs. And then on top of authentication, you can go for authorization and governance. I'm not going to divulge too much into it, but the SPIFFE spec, as it stands now in the open source, solves the bottom two layers. So it gives you an identity, it gives you authentication. You can use them for authorization, but that's things you need to build yourself at this moment, or rely on vendors to do that. And then the governance is also up to you, but it gives you all of the necessary building blocks to do that. So we now have talked about what SPIFFE is and what the problems it can help solve. SPIFFE itself is an open framework, so when you go to the SPIFFE GitHub repo, it's just like a bunch of README files that you can read through, and it explains you the SPIFFE spec. Of SPIFFE, there is a production-grade implementation in the open source. In the same SPIFFE project, you can find Spire. Spire has been run by big companies in production. A notable example is Uber. They have publicly blogged about it, definitely worth read. But we're going to now discover how a workload can get a SPIFFE identity and what SPIFFE identity actually is. And for that, we're going to start with the status quo. As we talked about earlier, in a lot of cases, we have a secrets manager in our environment. And let's say app B needs to connect to application X and get something need to get some information. So the way this would work when you use currently is with your application B, you're going to get a secret and client ID that allows you to communicate to application X. The secrets manager is going to give you that back, and then application B is going to initiate the connection to application X and send over that client ID, and that then can be verified by application X. One of the problems is it's not encrypted, it's not MTLS done, and also like you cannot really 100% know that it comes from application B unless you're actually like doing IP allow listing, but that doesn't really work in cloud and cloud native environments where IPs change and like it's a really fluid environment. So we want to get away of like these kind of things, and that's where SPIFFE comes in with all of its components. The SPIFFE framework exists out of the 5 distinct components, where each kind of has its own function, and we're going to now go over one by one. So we're starting with SPIFFE IDs. To human, that's comparable to how we called and like how we call ourselves. And the SPIFFE identity, as we saw earlier as well, looks very similar to what a website URL would look like. And it exists out of the following: the standard scheme that identifies what follows will be a SPIFFE identity, the trust domain, and this is to identify distinct domains of trust. Like, for example, one enterprise can have multiple trust domains, like to showcase multiple environments that shouldn't be connected to each other, like let's say, for example, dev and production. And the last part is the path, and that's how you can identify your workloads. Each workload should have its own unique path. The path can be a unique UID that you're randomly generated, or a more meaningful one, which is the case in this example, where it's the web server of the front end that runs on node 10 in data center 1 of our Venafi.com trust domain. So we're now going back to our application on 2 distinct servers. And we have removed the secrets manager because we don't need it anymore. So let's say I have a SPIFFE identity. I'm connecting from application B to application X, and I send over my SPIFFE identity. Application X is able to verify this, and it also can uniquely identify this is coming from me because like the identity is really attached to my application. It's not shared, so I know that it's there. One of the problems we're still having, it's not encrypted because like an identity, you need to be able to prove that. And that's where SPIFFE verifiable identity documents, or SVIDs, come from. It's comparable to our passports we carry around and how we can get verified at border control. So a SPIFFE verifiable identity document, or SPIFFE SVID, in short, is a cryptographically signed identity document that can be used to verify the identity of a workload within a specific trust domain. It is a fundamental component of the SPIFFE framework, which aims to provide secure and standardized identification and authentication for services in distributed and dynamic environments. Currently, JOT tokens and X509 certificates are supported as cryptographic key materials, which can cover a lot of use cases. And as stated before, certificates have a short life cycle. Like most SPIFFE SVIDs only live for a couple of hours and then they get automatically renewed by the underlying system. An example of like such an SVID in X509 format is this one, where the URI of the SPIFFE ID is being added to the subject alternative name. And for a JOT token, we have the same kind of payload as there with like our SPIFFE ID in front of it. And these then can be used to give like the public keys to external sources, and you're able to verify this thanks to our common root of trust, which is signed by a CA, for example. So we're going back to our application on 2 distinct servers, but this time instead of just the SPIFFE ID, we're going to send the SPIFFE ID encoded in an X509 certificate that has been signed by a CA. So application B is going to again initiate the connection to application X, and not only this time the SPIFFE ID, but the whole certificate, or the public key at least, is being sent over to application X. Application X can verify this because it gets like it from the same CA as my other identity, and because they have a shared CA, it's being able to verify. And because we have been using X509 certificates, the connection is also fully encrypted and MTLS secured, so like no snooping possible anymore. So we still need to get a way to get our applications their SPIFFE SVIDs because we need to get them to their system. And also, like, how can we issue identities in a trustworthy way? And to start solving the first problem, to getting identities to our workloads, SPIFFE has something called the SPIFFE workload API. It's like requesting our passport at the passport office. We need a way to get SPIFFE verifiable identity documents to each workload. The SPIFFE workload API, it runs preferably on a local socket, on a specific virtual machine or node, or at least only listens to a local host of a node. And the reason that this is required is because it's unauthenticated. The API is a way to retrieve SPIFFE SVIDs. It is also responsible for the automatic renewal and rotation of our SPIFFE SVIDs, as we want them to be short-lived. The workload API allows you to create integrations for your different platforms that deliver SPIFFE SVIDs directly to your application on a well-known location. For example, for Kubernetes, like this is a solved problem. Like you can get like SPIFFE SVIDs directly to next to your system, and it's very easy to get them, and like the ecosystem around it is very strong. But imagine a life that wherever you run your workloads, you have SPIFFE SVIDs. For example, an AWS Lambda function, an on-premise VM that's not even on Kubernetes, to even mainframes. There currently the implementations are existent, but a bit harder to get to, or sometimes even non-existent like mainframes. But like, it's a future we can dream of, hopefully. So the SPIFFE workload API itself is an authenticated API endpoint, and hence why it should only be locally reachable. It's also responsible for validating and attesting the different workloads that run on that node. This happens out of band, otherwise we wouldn't really be solving secret zero, but more on the attestation and verification later. So we're now going back to our application, and we have added the SPIFFE agent to each of our servers, and they have like a workload API endpoint, as like it's a local socket or local host, like it needs to run locally on the specific nodes where the workloads are. So what's going to happen is application B is going to request this SVID, and the workload API is going to return this SVID to us, and we're going to repeat this for all our other workloads. We're going to open up the connection, send it over, it's MTLS encrypted, and it's all secured. And this is our way to now retrieve like the workload API and be able to get like our SVIDs. We now need to be able to attest our SPIFFE workloads, and we need to be able to make sure that the workloads are who they say they are. The verification of workloads can be happening in band, as that would require API keys, and we wouldn't then really be solving secret zero. Verification and attestation of workloads need to happen out of band or asynchronous. And for that, verification and attestation happens at two levels. First, we need to trust the node, as that is where the workload API is running on. After we trust the node, we can start trusting workloads running on that node. To be able to build up that trust, we need to gather evidence of the environment the node or workload is running on. For nodes in cloud environments, this can be done through everything like querying the instance metadata of like the cloud environment and retrieving facts about it. In on-premises system, this can be done through TPM or other environmental verifiable data. Once a node is verified, the workloads that are running on a node can also be verified. This is again done by verifying the environment. Proof can be gathered from, for example, the Windows or Unix sockets, or when running in Kubernetes by gathering proof from the Kubernetes API and the kubelet. Like this might be all a bit hard to grasp, but like we're going back to our example, where we now have added a SPIFFE server. That's also the one that's controlling the CA. And you can see we have like added some extra endpoints. We added the node attestation endpoint. We added the workload attestation endpoint to be able to verify all of this at the start. So let's say a server 1 comes up. It's going to also bring up our SPIFFE agent. Our SPIFFE agent is going to gather proof of like the environment it runs in. This can be from the TPM that's where the agent runs on, or like from the cloud metadata. It's going to send that proof of node over to the SPIFFE server. The SPIFFE server is going to verify this on its own, and once it is okay with the information it got, it's going to mint a SPIFFE SVID. It's going to send that back over to the SPIFFE agent. It's going to repeat this also for the other agent, and now we have trust in our servers. We can trust them, we have verified that they exist and they are true, and that they have not been tampered with. So that means now our workloads can request an SVID from the workload API. The SPIFFE agent is going to verify this workload, and it's then, once it's verified, it's going to give us a SPIFFE identity that then can be used for doing the exact same things as the previous steps, and we get to like an MTLS connection. And I think I'm running out of time, so I'm quickly going to skip over probably federation, but federation allows you to federate between multiple trust domains. So when you want to be able to communicate, for example, with like another trust domain, as you might have like a production, a development, but you might have a shared environment, and you still want shared and production to talk to each other, you can then do federation between two trust domains and be able to talk to each other. But I'm running out of time, so I'm going to quickly skip that.
No stress. No stress.
Yeah. So before ending this talk, like one more word of the head of security and CISO of Notable, that SPIFFE is a game changer and how it helps simplifying TLS distribution to host, because like SPIFFE can then be used like for everything. So we're ending this talk a bit about the summary and what we have seen. So SPIFFE provides foundational identity. It is there when your workload comes up, it's just in time, and it gets destroyed again once your workload is gone. So like it's like really short-lived, limited in lifetime. It reduces the need for API key distribution because like SPIFFE can be used to federate, for example, with anything that's OIDC compatible, like think about AWS, Google, Microsoft, any SaaS service you might be using. So like you can then use your SPIFFE identity with a JOT token, for example, to authenticate to it. Our identities are short-lived and they automatically get renewed when it's required. All of the attestation happens out of band through TPMs, through cloud metadata, by looking at our Unix sockets. It's making life easier for developers because like they don't need to start wondering like I need to get a secret in a secrets manager, I need to retrieve that in a safe way. When the workload is there, the identity comes up with it and they can just find it through a common path and it's there and like they don't have to worry about it anymore. Spire is the open source implementation of SPIFFE. It's definitely, if you're interested in this, definitely check out the project. There's a lot of development happening in that community, and it's very easy to at least initially get up and running. Productionizing is a bit more, difficult, and that's like where, for example, we with Venafi are doing quite a lot of research around. But like definitely, it's a great open source project. I run it in my test cluster, and I experiment it with every day. And also, like, yeah. As we talked a bit about Cert Manager before, Cert Manager supports part of the SPIFFE spec. Like it doesn't implement the workload API, but it gives you like a SPIFFE SVID that is signed by a CA that you then can use for MTLS communication. And that's it. Any questions?
Just quickly to say, you might think, oh, what are you selling? Genuinely, we're not selling anything at the moment. Like this is quite new. But it is very powerful, and what we're trying to do is find design partners with which to kind of build out some of this technology to prove it out. We've proven it already with a couple of customers, but we need more. So if this looks like it's something that is interesting to you, like you have our time at the moment because we're working with customers to do that. So I will just...
and we're also always looking like to understand more problems. Like we have a kind of the problem space that we have found is like identities in multi-cloud. Also on-premise is like a big thing because currently there is not really an identity provider that can give you that. And like we're always looking for more like problem domains to kind of figure out more on like what the potentials are because like we think there's a lot possible with workload identity. Like for example, like one of the things I'm currently preparing another talk and we want to use SPIFFE identities for doing container signing in our CI/CD pipelines, for example. So like there is quite a lot possible there. Any questions?
Yeah, there is one question over there.
I was wondering, as an attacker, if I get hold of an SVID, could I just communicate to the target app and, you know, just use that SVID to authenticate myself wrongly as the app B in that scenario? Would that be possible, or?
Yeah, that would be possible. And the things that they're trying to do with the system there is trying to make the SVIDs as short as possible. Like I have seen cases where they're only 1 hour, for example, so that you can kind of only exploit them for 1 hour and like reduce the attack vector. But yes, it's possible. That's why with the SVID, once you get like hold of that one, you can at least authenticate to other systems within the same trust domain as like it has been signed by the CA. But you not necessarily are going to get in because you can do deeper authorization on your SPIFFE identity. Of course, if like two systems are allowed to talk to each other because of like it's for normal usage that's required, it can be exploited, and you can do like traversal attacks, let's say, and do discovery around in the environment.
Thank you. Follow-up question then. Could I, if I'm moving inside a pod, for example, and could I communicate to the SPIFFE trust server and, you know, just request a new SVID?
If you have access to the local socket, yes.
Okay, yeah, thanks.
Thank you. Oh, perfect.
That was the same question I was about to ask. So that's a huge risk, right? If a hacker can get into one server, they can get into all the nodes of the cluster, for example.
No, well, once they get access to one server, they can mint SPIFFE certificates that are allowed within that server, not for other nodes and other things. So like it's like really limited, like it tries to reduce the blast radius as much as possible.
What I meant to say is it can get into the second server, and from second server it get the SID, then go to the third server, and on and on.
Yeah, but then you need to exploit, like, for example, like each of your applications need to have the same vulnerability, and you need to be able to enter that one kind of thing. So in a zero, like as stated earlier today with Zero Trust, it's multiple layers. Like what SPIFFE does is help with like network encryption and giving you that identity to be able to authorize and authenticate requests. You of course have like still also the runtime security that you need to get right, and make sure that like CVEs are not there, that like you have closed off like any gaps in your application, because that's where then that exploit factor comes in as well.
Okay. Think about if server 1 crashes, and there are multiple applications running on server 1, they all want to fade over to server 2.
Yep.
And everything will start connecting to the CA server. So will that delay a pod coming back online, or what is the...
No, so the way that things work, when a workload gets moved to another node, that node will do the verification, and it will make sure that like it's ready to give like the certificates there. And it's really aimed towards high issuance. So like the CA, for example, is in memory. It's also like as short-lived as possible, so it gets rotated quite quickly as well. But it's in memory, so it can do these high-speed issuance. Like we've seen environments with like 10,000s of workloads running without any problem. Like Uber, for example, ran it at really high scale with the open source Spire without any problems. They helped actually with improving as well the reliability and scalability of Spire itself. They blogged about it, so like definitely worth a read. Like if you Google Uber SPIFFE, you will find it.
Yeah, to be honest, half an hour ago I had never heard about SPIFFE at all. So thank you for introducing us the tool, the framework itself. Thanks, Matt, and thanks, Matthias. And yeah, do we have further questions?
And we're still around here, and we might get some drinks later. So if you want to join us to the bar, and talk about workload identity and SPIFFE, always happy to do that. Also, we talk about other things.
Sometimes.
Sometimes
Kubernetes as well. Good questions. Thank you.
Thank you.